Hey friends, welcome back on my channel. So today we have the second video of our SimTime series, and today we are going to have a look at how you can download CAD models from SimScale, the public projects library, and import these CAD models that you have downloaded into KeyShot 8, render them, have a look at the environment, how you can use the KeyShot environment, set up your animations, export them, and create awesome animations as you have seen in the preview that I've uploaded on my channel. So I would say without further ado, let's jump right into the environment and let's go.
So we are here at the SimScale website right now, and for those of you who have seen my last SimTime video, you already know how to log in and what the website is all about. So I'm already logged in, as you can see in the top right corner. If you're not logged in, you can either see the login button or the register or sign up button. And as always, you can find all the relevant links down in the description, so I'll put everything there in case you have any doubts. So I go to the dashboard right now, and what I can also do, like either load a project that I already wanted to render, or I can go directly to public projects. So you can type in PCB, which I now did, and you can see every PCB or printed circuit board that is available on the public projects page. And if we scroll down a bit, we can find the one that I used for the preview, which is this one. So if you like the CAD model, you just click on it and then just copy it by clicking on this button right here, and it will be copied to your dashboard, which is like your workspace for all your projects. I already did that, so I can go back to the dashboard. I have here the PCB desk, can open it by clicking on the blue arrow button right here, or this icon. Now I'm inside the project. I don't want to perform a simulation, but rather grab the CAD model, which is the Arduino Nano. I choose the context menu and click on download, and this will download the geometry and the zipped file, as you can see right here. You unzip it, put it into a location preferred to your needs, and then you can use it and import it into KeyShot, which is the next tool we are going to use. So this is KeyShot here. You can have a look at their page and what you can do with it. You can already see it on the front page or the landing page. It's quite impressive, to be honest, and I have used it for some projects in the past when we had like mechanical design. Some people might have access to this software depending on which university you are studying in, and if not, you can also either get the academic version, which costs like $100, so $99 I think, or you can also choose a test version, click on try, fill everything out and fill everything out, and you can try KeyShot for free. So if you want to buy it, you just click on buy, click KeyShot, and here are some licenses. But if you are an academic user, you scroll down, go to education. Now we are at the KeyShot education page, and you can see that KeyShot 8 for education costs like $95 per year, so not $99 as I told you. So it's quite cheap actually, and there are also some plugins that you can use, which will follow in one of the other SimTime videos. So you can also go to the resources, then downloads and plugins section. Then you can find every plugin, and we will cover that in a future SimTime video. So we will maybe use Onshape or Creo, and we can create, let's say, an engine or any other assembly, and then render it with a KeyShot plugin, and I will show you how you can do that in the future series or in the future SimTime video, to be precise. So once you have downloaded everything and set it up, you can open KeyShot. In here's the project I showed you in the preview. So we created a new project now. We click on import or Control I and choose the Arduino file. If you're not sure what the orientation looks like, you can either guess, or what you can do is you can go back to SimScale, and we have a look at the model right here and see what the orientation looks like. So Z is the direction up, you can see it. Z is the direction which goes to the top. So we choose up orientation Z, import the model, which takes a few seconds, and here we are. So very nice. You can see it kind of blurs a little bit because it renders all the time when you release the the mouse. So the left mouse key can be used to rotate the object. So the right mouse key is to use the context menu if you want to do anything with the object. And the scroll wheel, of course, is zoom in, zoom out, and clicking the middle mouse key is panning around. So we have a standard light condition right here. As you can see, the Arduino is on the floor. What we are going to do now, we close this project tab for a moment and open the library tab. And in the library tab you have several materials that you can choose from. So let's just start by using this anodized aluminum brushed black. Of course, these cones here should be not black. Maybe we can argue, okay, maybe it's painted, but it's just for the sake of demonstration. And for the contacts we might use gold here. That looks good. Then we also use maybe gold for the contact inside of this. Yeah, looks quite cool. Then it's really up to you what material you want to choose. You can be very sophisticated here and do all kinds of things, but it's just to show you how you can animate this, and in a future episode I can show you how you can do it in more sophisticated ways and really polish your renderings. So we choose this anodized material as well for these parts. Then maybe choose another material. Let's see, maybe chrome for this one. Looks okay. And then maybe some stylish color, maybe blue. This looks cool, right? Looks quite cool, to be honest. So we now have every part basically with the material. Some of the materials downside are connected to the ones to the top, so it will automatically assign the material to them as well. So we didn't do the bottom side. It really depends on how your model is modeled. If it's a top-down approach or bottom-up approach, it's really up to you how you want to do this. So the next thing we are going to do is to apply my logo on this chip, and this is basically very easy, and I'll show you how you can do that. So go on project, double click on the material for the chip, then we go to labels, add a label which is texture, then here are my logos, and we choose the white transparent. Looks quite good. And then there's the coordinate system. So first of all, I want to show the translate options. So these things here pop up, and also fit to Z. So it will be fit to this Z axis, and then just move it around a bit. Maybe just close this project here and this library for a minute, just to be precise here. So here we are. Let's say we are fine. We can click on the screen OK button, and it looks amazing, right? Very nice, very cool. The last thing that's missing right now is the animation function. So let's just say we start from this perspective, from this camera perspective. Then we click on the animation wizard, or what we can also do is click on project, go to the scene, click on the Arduino, the whole part, right click, animation, and then rotation or turntable. But right now we use the animation wizard, which is like very convenient for beginners. We use turntable, choose next, choose our Arduino, click next again, and let's say we want to rotate for 460 degrees, and we make it not linear motion but ease in, ease out, which smoothens the start of the animation and the end of the animation. Click finish, and let's just do it. We extend it by 10 seconds. So let's do it 10 seconds. And over this 10 seconds, it rotates for 460 degrees. So this is a nice end position. Looks quite good. Yeah, looks quite good. So we can also preview it by clicking on this play button, of course. And we say, okay, it looks quite cool. And you see it slows down at the end as well. This is this ease out. And for the ease in, you can see that it starts very slowly and then accelerates. And of course at the end then eases out, as I previously mentioned. Quite cool, right? Okay. Click on pause. Then what we do next is we select the components. Please note that once you scroll in, the camera of course changes, and that's a separate topic for itself. So you would either have to create a new camera and adapt the settings, or you just go back to the azimuthal angle and or the angle like you had the look on previously. Let's say if I turn it like this, okay, just to explain it a little bit quicker, you will see that the orientation stays the same. And we of course, if we start here, we can of course use the animation wizard again to change like the angle and the orientation, but that will follow soon. We are happy with that right now. What we do next is to choose the chip. So we have, this is the chip, so I'm quite lucky that I got it now. Click right click animation, do translation. I changed not the global axis but the original ones. Don't want to translate it to Y but Z, with a distance of 0.04. Let's see how it looks like. You see it goes up. We can also ease in the shift a little bit so that once it starts rotating, but I want to not do it linear motion, ease in, ease out, also slow it down a bit. So if you go back to the start and play it again, you can see it slows down at the end and of course starts very slowly as well. Let's say we are happy with that. Okay, we save it right now. Let's just save it. Always make sure to save it in case it crashes and then you can do anything. Okay, next thing we are going to do right now is to choose the other parts. Let's just say we choose the top parts. We have to look a little bit, either you named them correctly or you know what you have chosen. So this is one part, and then the top part is this one. So we choose this one and this one. Translation. And now it's quite, let's see, it's not epsilon, it's we can use X. We use this one. If you're not sure, you can, I mean, you can test it. You chose the original local again. It's the wrong direction. You see it goes like into the Arduino, so we have to choose a minus. Minus looks good, but it's not. I want to go outside. 0.02. Yep, looks quite good. So we do the same with the small part on top of the golden part. Click on animation, translation, original, 0 and minus 0.02. It's the same, and we have to align them to make sure both move at the same time. Yep, looks good. And we do the same of course with the others. So this was the other one, then this was the top part. We do again animation translation. We do it very quickly now because you get the point. Minus 0.02, choose original local. It's fine. We want to shift them a bit so that it not animates at the same time, but use more dynamic movement. Then we choose this top part as well, animation translation again, minus 0.02, 0, and of course use again the original local. Then we move it to the other part, like align them. What we forgot is ease in, ease out the animation. We do this with every animation we did so far. This is linear as well, ease in, ease out, this as well. And we continue doing this for the other parts as well. And also translate this part, this is the last one. To couple both, you choose original local, align them, and let's just see how we did. We start at the beginning. Oh, they're not aligned. because they're not ease in, ease out. You see, there's one mistake. If I would have done it linearly, you can see that there is there's a shift between both. You can see it right here. You see, they're not at the same position, and there's a delay. And there you can see that I already made a mistake, and that's just that it's linear, and the other one is ease out. So we ease in, ease out both, and now they're aligned. There you go. So we start here again. Maybe I think the chip is quite too high. Maybe we can do it a little bit lower, like this, but it blocks then the view on the small parts. Let's just see how it looks like. Yep, it's quite okay, I guess, right? So we just leave it as it is. You can do, of course, translate the smaller parts as I have shown as well. What we want to do now is to mirror the whole animation. So mirror, I will show you what this does. It would basically shift back the animation. You see, we've chosen the part and goes back in, but I want to do this with the chip, so I mirror the chip, choose this one, let this go back, then drive the other ones back in. Looks good. Then I click one, and then hold shift to select both, click mirror, and I have both, select both as well, and then also shift them right here, select them, mirror, shift this here, then choose the last ones, mirror, and mirror it back. So let's just have a look at this, like how it looks when it goes back. Looks good, right? Okay, we turn off the looping, save it. So one thing that's missing right now, we want to make it translucent. So fade a little bit and give it an opacity. So for that we choose the Arduino, or just choose the animation wizard, click fade, next, choose the Arduino, but not the whole, but just the PCB itself and not the parts, the components on it. And we say fade from 100% to maybe not 0, but maybe we go to 50% so that we can see through but still see some of the parts. Let's just go with 50% here. Also ease in, ease out, finish, and then we have it at the very bottom. Yep. You can of course extend this a little bit. Extend this and then mirror it again to fade it back, like to full opacity. Maybe like this. Let's see how it looks like. It would fade here. Maybe 50 is not that good. It doesn't look very pleasing for the eye. Maybe go less. 40 looks okay. So you can see here it fades out. And then once the animation goes back, it goes back to full opacity, like 100%. And that looks quite impressive, right? So let's say we're happy with that. We can also decide if we want to zoom in, like how I did in the preview. Say if it turns again, then it zooms in. For that you can just use the animation wizard and play with the zoom. You can see this is the zoom and it gives you some idea of how it looks like. It's just zoom, then you can orbit with the camera, you can use panorama, dolly, path, DOF, translation, and camera switch event. So it's really up to you. I use the zoom option in my, I use the zoom animation in my video, in my preview as well. You can do that, but we'll keep it as it is right now. What we are going to do now is I show you how you can render this whole thing. So we close the project now and click on render, and you want to do an animation. So what I did is I chose an animation of 2560 on 741, and of course the higher you go, the longer it will take for one frame to render. I did 10 seconds, which is approximately 301 frames, so it's it's like 30 frames per second. You choose the name, the folder of your output, the format, and you can also do a little bit more sophisticated settings like diffuse, reflection, clown, lightning, but we will cover that in a future video because it is for more advanced users. And I just want to get you started in the animations and what you can do. So once you're happy with that, you can click on render, and it will render every picture, and depending on your memory it will either be slow, fast, very slow, or very fast. Like for me it took around, I'm not sure, like 1 hour, 1 to 2 hours until I rendered my video. So it really depends on your setup, but you should have a strong computer. You can also download some files for network rendering in case you want to render in a network. You can use it for Windows, Mac OS, or even Linux. And I have it installed on both, and I can tell you it works very well on Mac OS as well as on Windows, as you can see right here, because here we're on Windows, of course, and I rendered mine on Mac. That's the whole process. If you have any questions, feel free to leave a comment down below, and I will make sure to help you out in case you want to test for your own CAD model.
So I hope that you enjoyed this video, that you learned something out of it. As I already mentioned, some other KeyShot tutorials will follow in the future, so I thought about maybe creating a V8 engine or something similar, and we would model this inside of a CAD software and then render it with a KeyShot plugin. So that is definitely amazing, because when I did my internship I did something similar and it looks just incredible, way better than what we did today. So if you are interested in that, feel free to drop a comment down below. And what we can also do is, if you have a Formula Student car or any other cool assembly that you want to simulate, you can send them to me and we can do some kind of series where I take CAD models from you and we polish them and make them look very awesome. So if you have any interest in that, feel free to contact me, send me your CAD models, share them with me, and we'll make it happen. If you have any questions, as always, feel free to contact me, as I just mentioned. Subscribe if you haven't already, and as always, make sure to keep engineering your mind, and see you in the next one. Peace!